Back there? Okay. First off, thank you, Paul, and thank you, Barbara, for making this evening possible, and thank you to ResNet for hosting. It's great to see everybody out here tonight. This is probably one of the bigger attendances that we've had, so thank you all for coming out. I wanted to talk today about building a RESTful services and what the RESTful web services can give us as a way of an advantage over traditional or legacy ways of building web services. So in order to do that, we're going to talk briefly about the history of web services, what the background was, what the trends were, and what the problems were with the existing legacy mechanisms and why we wanted to go with the newer way of doing things. And so before we get started, I wanted to take a quick selfie of myself with all you guys in the background. So if you could, please smile and wave so that we could get a nice little picture of all of us. Woo! All right, on three. 1, 2, 3. All right, thank you all. Last speaker, I think last month or the month before did that. I thought that was great. Okay, so SD Jugget, yeah. Oh.
SD Jugget.
Okay, I like that. Okay, put it on Twitter. Ooh, I like it. Paul's always thinking of marketing. All right. So let's see if I can actually, there we go. Okay, so my name is Anurup Joseph. Wanted to give you a brief overview about myself. I've been coding since about '83, so you can see that that's kind of my passion. I've been coding professionally since '94. In Java since about '96, '97, which is kind of really near when the 1.0 of Java came out. I've worked in many different industries and different geographies, from the Midwest to Silicon Valley, San Francisco, to LA and the entertainment industry, telecom industry, computer software, hardware industry as well. And essentially what I generally find about myself is that I just love to explore new concepts, new technologies, new places, see new adventures, and of course, the best part of experiencing new things is sharing them with others. Sharing them with others, fostering what my passions are, which is Agile development, as well as continuous integration, continuous delivery. I also like to volunteer here in San Diego. I volunteer with a group called the League of Amazing Programmers. We teach underprivileged children Java programming as a means to basically find a leg up and basically get a skill set that could hopefully allow them a path into the middle class. Paul Weber was actually part of the board for a brief time, so Paul's very familiar with that group. So if you're at all interested...
7 years!
7 years, my goodness. So if you're at all... So if you're at all interested in just bringing out the joy of programming and sharing what we enjoy doing with kids, I totally recommend it. It's a wonderful organization and a wonderful way to volunteer and make a difference in kids' lives. Okay, now that I've talked about myself, I want to ask about you folks. Now, this is a talk, again, on RESTful web services. Now, what I wanted to ask is, have any of you guys heard of REST at all? Show of hands. Okay, who's using REST? Okay, so almost half of you. Okay. Anybody using older technologies of web-based or interprocess communication, such as Corba or IIOP or SOAP? Anybody using those technologies? Okay, few hands. It sounds like most of us at least have heard of REST, and about half of us are actually using it. So that's good. So it won't be totally new to most of you guys. But I will, because at least half of you had said you haven't used it, I will cover some of the concepts, but we won't go into it as much detail because you've heard of it. Now, in terms of message formats, of course, computer processes need to exchange information with other computer processes and their message formats in order to do that. How many of you are using XML to transfer information back and forth? Okay, good, about maybe a third of you. How about JSON? Anybody using JSON? Okay, about the same number, actually. Is anybody using something else other than JSON or XML? Show of hands. No? Okay. So that was about 2/3 of you. The other third of you are not using any technology to communicate between each other. So that'll be interesting. Perhaps it's telepathy or some other form of communication. But that's good. That helps me understand what exactly my audience is familiar with. Now, lastly, what does anybody use any technologies for documenting and testing web services? Anybody use any sort of technology to do that? Anybody heard? Okay. Has anybody heard of or is using Swagger or OpenAPI? Okay, so a handful of folks. The rest of you, just show of hands. Does that mean you're not documenting your web services or not having any sort of automated framework to test your web services? Is that right? Okay, I see some hand shaking. All right, okay, or head shaking. So I guess that's useful. So, okay, this is good. So it sounds like you're familiar with REST, you're familiar with JSON, so we won't need to cover those topics in too much detail. But I think what you can get some value out of is the latter part of my talk, which is using a technology called Swagger, or renamed OpenAPI, which is now the world's most popular API documentation framework to be able to document and test your code, and specifically show you how to use an implementation of that called SpringFox, which works with Spring-based Java Web Services to be able to do this kind of in an automatic fashion. So let's get started. Okay, what are we going to talk about today? So we're going to talk about how processes communicate back and forth, inter-process communication. We're going to talk about communication mechanisms, so what is the means by which processes can communicate with each other. We're going to talk about various message formats that are used by processes to communicate with each other, as well as the last topic, which is documentation and testing. Now, of course, we'll, time willing, we will do a demo, hopefully a live demo, and hopefully the demo gods will be kind with me and we'll be able to see the demo go without any bugs or something. So let's see how that goes down. All right, let's start off with inter-process communication. What's the concept? Well, the concept of inter-process communication is that you essentially have a series of services. Each service ideally does a small amount of work that is logically aggregated. And then, by agglomerating the services together, the concept is called chaining, we can maybe build up more complex functionality by calling a service from another service. What's an example? Well, let's think about you're running a store, maybe a pet store or something like that, okay? Whatever the product is, you have to have inventory, so maybe your order-taking system interacts with the inventory system. When the customer purchases a product, maybe the inventory system deducts the exact number of units from the inventory, and maybe when it goes below par, it submits a request to the order processing system saying, hey, we're below our threshold of this particular product, we need to order some more. Maybe you also have a tax processing system, and the tax processing system takes the incoming order and based upon the appropriate business rules, perhaps the billing address of the customer, calculates the appropriate tax, charges the tax, and registers that for the appropriate taxing authorities. Again, just an example of how different services can be chained together to perform business functionality. But in order to do that, the services have to talk to each other. They have to engage in inter-process communications. And these services, of course, are producing their web service producers, but they can also be web service consumers. They can consume other services. And if they can access each other over web protocols, then they are web services. And pretty much in the industry today, everyone wants to do web services so that we can leverage a lot of the technologies such as HTTP and use browser-based technologies to be able to access our services. Now, with inter-process communication, of course, we enable service chaining. And if these services are very small and self-contained units of logic, we have microservices. And microservice chaining allows us essentially to build pipelines of more complex business logic. The next thing we want to talk about is SOAP. What is SOAP? Well, many of you told me that you've heard of SOAP. Well, it's an interesting acronym. It actually was an acronym for Simple Object Access Protocol, which is kind of comical in my opinion, because if you look at the SOAP specification, simple is not the first word that would come to my mind. If anybody's used SOAP, it is not simple. In fact, it's, I think, rather complex. But why do they call it simple? Because believe it or not, it is actually simpler than a much older protocol called Corba that was used in the late 90s. Now, Corba was insanely complex. It was something that was good for tearing your hair out and occasionally for inter-process communication. SOAP was a simplification of that. It was originally an acronym for that, but now it just means SOAP. It has no meaning anymore. Now, SOAP used a concept of basically a rigid set of descriptions and descriptors that can basically allow services to communicate with each other and define a contract with each other. It was originally developed by Microsoft in 1998 for their service communication. There's some, like little bits of history there where Microsoft didn't want to allow that to become a standard, so some of the people who were working on SOAP decided they were not going to wait for Microsoft to make it a standard and created XML RPC, which is yet another interprocess communication system. So anyway, it was a whole Wild West back in the late 90s, early 2000s, and eventually SOAP took over once Microsoft allowed it to become standardized. Now again, it is simpler than a much earlier, more complex protocol, and it uses the concept of messages to send requests and responses to each other, back and forth, and the concept of faults to communicate errors. Now all these are specific messages and specific descriptions tightly bound to a specification, and there were tools that could actually generate client code given a SOAP service. Now the major components of it, I'm not going to go into too much detail, but the major components were this thing called a WSDL, a WSDL, or a Web Services Definition Language. It was a document that essentially described the contract. It said that I am a web service. This is what I take in as a request. This is what I give back as a response. I listen on this port, on this URL, and in case of errors, I return this particular SOAP fault. There's also XSDs, or XML schema documents. These are used to capture the contract of the actual message. In other words, the message going back and forth is tightly bound to an XML schema definition, and that defines the particular document format or the message format passed back and forth. Now, all this, as you can see, has a lot of overhead. It's very tightly bound, it's very rigid, very inflexible, and it also, but it also had a large body of tools that supported it. And all the documents that I'm telling you about, the WSDL, the XSDs, the actual messages for input, output, and SOAP faults, they're all XML based. What's XML? Well, we already know this, I'm sure. XML is an acronym for Extensible Markup Language, right? It's basically, or initially started as a human-readable message format. Instead of a binary protocol, let's use a text-based protocol to send information back and forth. It worked great for the time. Well, when we look at XML messages passed back and forth for interprocess communication, we'll notice a certain fragility a little bit later in my talk, and we'll see maybe another way of representing data that removes a lot of the duplication and a lot of the ceremony that XML brings with it. So the overall theme for this talk could be removing ceremony and getting to the heart of the matter. All right, now XML, as we said, was considered rather verbose. Well, what's an alternative? Who here has heard of JSON? I think most of you said yes. Okay. JSON is originally an acronym for JavaScript Object Notation. This is how JavaScript natively represented data in its memory. JavaScript natively used JSON to be able to essentially represent data. And so JSON naturally arose from that. And it was invented by a man named Douglas Crockford, who's now the senior JavaScript architect at PayPal. Now, what he did was he derived it from JavaScript, but it is now an independent message format, meaning the message format originally came from JavaScript, but there's nothing requiring you to use JavaScript in order to create and consume JSON, to produce and consume JSON. All right, and now JSON is considered, of course, less verbose than XML, and we'll see some examples that will show us why the industry is rapidly moving towards JSON and rapidly moving away from SOAP. So let's take a quick example. Let's think about a class database, maybe a database of a school teacher. Maybe a school teacher wants a list of, per se, students in the school teacher's class. Well, how do we represent some data? Now, again, this is just a canned example, but just, I just wanted to give you an example of what this data might be. In XML format, we might want to store data about a student, such as what? Well, probably we want the student's name, probably want the student's maybe age, we might want the student's grade level, right? We might want to store all of that, and that could be a record for a student. Now, obviously, in real life, you probably have much more complex data, probably much more attributes, but for the sake of just this tutorial, you can see that this would be representing a student record in XML. Seems pretty good, right? It works. It has a start tag and end tag showing me where a student starts and begins. It has a start tag and end tag for name, for age, and grade. So I understand when the name starts, when the age starts, and the grade starts, and when each of them end. Well, that works really well. Well, it's also a little bit verbose, don't you think? Could we get rid of a lot of that extra stuff? I mean, do I really need to have a start tag and an end tag for a name? How about using something maybe a little simpler, like maybe a double quote to represent something starting and something finishing? Well, how would we represent that? Well, JSON has an alternative way to represent a student record. So notice the first thing in JSON is a brace, which represents essentially a record begin, right? The open brace, or as we call it in the League of Amazing Programmers, the open mustache, right, looks basically like a record beginning. And notice we're storing the name, and the name just has the key in double quotes representing the name, a colon, and then the value, which is also represented in double quotes. Okay, so now we don't need the end tag, and we have a comma indicating that we have additional records after that, or additional key values. Age, now because 11 is an integer, or a number, we don't need to put it in quotes. If it's a Boolean, we don't need to put it in quotes. If it's a string, we do need to put it in quotes. So there's some syntax there, but otherwise, notice how JSON essentially represents the same information with a lot less ceremony. So just briefly, just to show you again, right? So we get the same format or the same data, but with a lot less duplication. All right, now let's talk about REST, or Representational State Transfer. But before we talk about REST, we need to talk about the person who came up with that REST. And if you attended my talk back in May, when I talked about extreme programming and test-driven development, we talked a lot about Kent Beck, because I think the history of who created what, because that gives us a little bit of idea of where they came from, what problems they were trying to solve in the solution that we're going to be talking about. So I think it just gives us more context and makes it a richer sort of experience. So where did REST come from? Well, it came from an individual named Dr. Roy Fielding. Now, Dr. Roy Fielding is actually, I think, one of the people that we don't know about, but we should. He's a principal author of a protocol that we might have heard about, HTTP, Hypertext Transfer Protocol, the basic underlying protocol of the entire World Wide Web. He's a principal author of that protocol, and he also was a co-founder and lead developer of the Apache web server project, meaning the most popular web server on planet Earth was co-founded by Dr. Roy Fielding. So he knows a lot about HTTP. He wrote the most popular, or helped write the most popular web server. He was also one of the lead architects of HTTP 1.1, which he based on his concept of REST, which we'll get to. Dr. Roy Fielding was also the former chair of the Apache Software Foundation for quite a few years, and now I believe he's working at Adobe as their senior principal scientist. So we really owe him a debt of gratitude, not only for that, but also for what he got his doctoral dissertation in. There's a seminal paper called Architectural Styles and Design of Network-Based Software Architectures, and that was his PhD dissertation, and that described, among many other things, a concept called REST. So, now that we know where Dr. Roy Fielding came from and how he personally designed HTTP to fit REST, let's talk about REST. REST is an acronym for Representational State Transfer. Now, the web, or specifically HTTP, there's nothing about it that maintains state. In fact, that's why Netscape invented cookies way back in the day, because the web was originally stateless. So, it's a stateless web communication protocol that uses essentially URIs, or Uniform Resource Identifiers, to locate services. In other words, I communicate with a web service at a particular URI. Now, a URI is essentially an implementation, the interface, the implementation is a URL, which is a network addressable URI. So think of it like a URI could be an abstract person, a URL is their exact address, right? It shows you how to locate a person. So the communication is with HTTP operations, which again, Dr. Fielding designed to be compatible with REST. Now, why would we want to do that? Because it gets the point across with a lot less duplication, a lot less verbosity, a lot less ceremony. In other words, we get the job done more efficiently. Who wouldn't be happier with that? And it's now become the industry standard. The last surveys that I looked at this were dated back in 2011, where RESTful web services compared to SOAP were taking about 60% market share. Bless you. 60% market share compared to SOAP services, and pretty much after that, you don't see too many other surveys because the industry's pretty much made the decision. The vote has been made, the ship has sailed, REST has taken over. Let's take a look at how that works. Now, we heard the theory of how REST works. Let's talk about how it actually happens in detail, right? How do we do certain operations? Now, when I use the term CRUD, does anybody understand what CRUD means? Okay, good. About half of us understand CRUD. CRUD is an acronym for the common operations that we would use, that any application would use, which is C for create, R for read, U for update, and D for delete. In other words, these are the common operations that just about any generic service would need to have. In our pet store example, for example, you'd probably need to create an inventory item, maybe read it when a customer wants to inquire some data about it, maybe update it if the price has changed, or the description has changed, or the quantity has changed, or something else has changed, and delete it if it's out of stock or you're not selling that anymore, right? So these are the basic operations that any application would need. Now, how does that map to HTTP? Well, remember, this is where the person who helped design HTTP and helped design REST kind of married the two ideas together. So let's take a look at this. All right, so we match HTTP operations to these CRUD operations. How does that work? Well, create is mapped to a post. Who here has done an HTTP post? Anybody filled out a web page form? Okay, so we're familiar with an HTTP post, right? You basically go to a web page, maybe it's like an address book or something. You enter your information, you click submit. Okay, and that does an HTTP post. The browser is actually sending an HTTP post to the web server. We'll see exactly how that goes in just a few slides. But that essentially creates a new document on the server. So back to my example, it's an address book, right? You're saying, hey, thanks for your blog or whatever, good comment or a good article on the blog, and you click submit. What does that do? It essentially creates a record on the server. So a post is the equivalent of a create operation. Okay, cool. Now, what about the next one? Read. Well, we're probably very familiar with that. That's an HTTP GET operation, right? And a GET operation is done whenever we go to any URL. Anytime you go to google.com, your browser is actually sending an HTTP GET to the server. That's it. That's what a GET operation is. It is just a read operation. Very simple, very straightforward. What about update operations? Well, update operations are actually two. Dr. Fielding created two operations or HTTP verbs for update. Now imagine back to our post of the address book, right? Say I wanted to, thank you for the article. It was very informative. Signed, my name, Anurup Joseph. But I realized, oops, I made a typo in my thank you message. I want to update that. So I go update it, and I click submit. Well, that would be a put operation or a patch operation, and that would be based upon whether we're replacing the entire document or we're replacing only a field or a couple of fields in that document. And that's when you'd use a put versus a patch. So again, those would be actual operations that your browser would send up to the server, and that's what web services can leverage. And lastly, the delete operation. Say I just decided, you know what, I don't even want my comment there anymore. I'm just going to click delete. I click the big red X. And that maps exactly to an HTTP operation called delete. So as you can see, the CRUD operations, create, read, update, and delete, are directly mapped to HTTP operations as well. And these HTTP operations can then be leveraged through REST to be able to communicate from the client to the server. Now, how does the server communicate back to the client? Well, here Dr. Fielding was thinking about this as well. And he realized that web servers, by default, communicate back to their clients using what's called HTTP status codes. Now, I think most of us are probably familiar with at least one or two HTTP status code. Anybody ever get a 404 on their browser? Okay, when do you get a 404 on your browser? Is it when you typed in the right URL? No. It's when you typed in the wrong URL, right? It's when a resource is not found. HTTP 404 is actually the status code that that the server returns upon errors. Dr. Fielding realized, well, hey, why don't we use this to communicate from the server to the client? We're already doing this anyway. Why don't we leverage this to be able to facilitate interprocess communication without all the ceremony of a gigantic XML document, without all the ceremony of a SOAP vault documenting exception and exception codes and anything else? Why don't we use the technology that we already have? And that's the concept, essentially, at its heart of REST. HTTP status codes are used to convey the reply. Now, what are the best practices of REST that we want to keep in mind? I put a URL here, which is a nice little URL on HTTP methods and when we'd want to use various ones. And so it's kind of nice. It describes what I was talking about before. Hopefully you can see this. It talks about post is used to create, right? Get is a read-only operation, right? Put or patch are used to update. Put for overriding the entire document. Patch for only updating a certain number of fields in the document. And delete to delete the exact document. Now, these are kind of nice because they describe exactly what the particular operations were and what what is best practice to use them for. Let me see how I can get this back. There we go. Okay, so that's a good URL to go to see what methods to use at various times. But if I could summarize, it's really pretty straightforward. You use get operations for anything idempotent. Now, idempotent is a fancy word. All it means is it never changes state. Meaning, I can call a GET request over and over and over, and it never changes state on the server. Here's an example. I'm gonna click refresh on my browser. When I click refresh on my browser, does that change anything on the server? No, I'm just getting the same document back over and over. So GET requests, your web service should do GET requests for anything that doesn't change state. And the formal terminology for that is idempotency, meaning you can implement the operation repeatedly without any state change on the server. Now, what about things that do change state? Well, any state change should be represented by the other HTTP verbs. We talked about them. Post, which creates, put and patch, which update, and delete, which deletes. So, read-only things, get. Anything else, non-get. Okay, what else can we do? Well, there's also the response, which are a nice little link right here on http status code.html. So if we go there, we can see that these are various HTTP status codes that the servers can respond with that are kind of helpful for us. For example, we generally represent 200 if the operation was successful. If we didn't find something, we give a 404. If maybe we got a bad request, like the input was invalid or something, maybe we do that. If the user required authentication or authorization and they don't have permissions to do the operation, we give back a 401. So you see, in this fashion, we're able to communicate back to the user or back to the caller without having to give back a huge document, without having to give back all the ceremony. Just very briefly with status messages, we can get the point across. Okay, so that's the status messages that we want to do, all right? Status codes. And then what we want to do is also something that I really believe in my heart of hearts. We only return output to the client that matters, okay? Here's an example. Imagine that the client is trying to do something in the database, and the database had a particular error, okay? We could return the details of the error to the caller. We could return the stack trace, but is the caller seriously going to do anything different because they have the stack trace or the exact error code? No. So if the caller cannot change his or her behavior based on the return code, based on the result, don't send it to him. Why bother sending data that isn't of value and only pollutes and clogs up the communication channel? That's the general principle. Also, think about it this way. It's a security violation, right? Imagine if I give back the exact security error message to the caller. Well, remember, this is a web service. This can be called by anybody on the web. And now somebody on the web knows the exact error code from my database? Well, what could a bad guy do with that? They could look up that particular error code, determine the particular database that I'm using, the version of the database that I'm using, then go online to various attack tables and find vulnerabilities for that particular database or that particular subsystem that I'm using, and then use that as an attack vector on me. So for the purpose of security, for the purpose of brevity, only give back what is absolutely critical to the client. And if you can represent it with just a status code, by all means, return a status code. Only if you need higher resolution than a status code can return, okay, then consider returning a body of a message instead of just a status code, which is in the header of the message. Okay? But when possible, try to use HTTP status codes, because it gets the point across, and you don't have to send over War and Peace or an entire novel. You just send over a very simple response. Now, let's check the time. It's 7:43. Paul, you want to go till 8, right?
Yeah.
Okay.
Anywhere that's good for you.
Great. Okay, let's go over some examples, and then we can call a short break. Now, these examples I mentioned before of how services actually talk to how consumers actually talk to producers, web service consumers to web service producers. How would this actually work for a create, read, update, delete operation? All right, let's take a look at a create operation. Say in our example, when this teacher has a student database and we wanted to add a new record for a particular student. Okay, well then the client would send to the server a post. Remember, a post creates a document, creates an object. So in this case, it submits a URL in the format of /student/12345. Well, in this case, okay, we're clearly creating a new student object. And 12345 is probably the ID of that student object. We then say the protocol that we're using, which is HTTP 1.1. And we say that we are going to be giving you, server, this is a client talking to the server, hey server, I'm going to give you application JSON. That's a MIME type for JSON. That tells the server that you can expect that the client is giving you a message in JSON format. Yes, question?
Why is your endpoint including the identifier?
Why is your endpoint including the identifier?
Normally, when you post, yes, you're trying to create a resource, and actually you don't know an identifier of the resource. Normally, post request comes back to you with the corresponding identifier.
Very good point, yes.
You're not actually supposed to be providing identifiers.
That's a good point, yes. This is just a canned example, but you're absolutely right. In fact, I could have not sent, the question was, why are we posting in the ID into the URL, right? And that's a very good point. It's a valid argument. This is just a canned example that I made. In actuality, you could just post to the student endpoint, and the server could determine the ID and send it back to you. You'll see why when I go to the other examples, because this was deliberately contrived for purposes of tutorial. But you're right. In the real world, you probably wouldn't do that. Now, the next point, the next line, content type, application JSON. That's essentially the client talking to the server and saying, hey server, I'm going to give you a message. It's going to be JSON format as opposed to XML format or plain text format or CSV format or whatever other formats that we can think of for representing data. Okay, and it's also saying, hey server, just so you know, I understand JSON, so feel free to send me back JSON as opposed to XML or CSV or plain text or any other format. Okay, so what's it going to send over? Well, this part we should be familiar with because we saw this before. So in this case, it's sending over a student record and saying, I want you to post it, meaning this is a brand new record. And the server will then respond. What will the server send back? The server will send back a message to the client, and it is HTTP/1.1, and this is a status code, 201. What is 201? Well, 201, if you'll recall from the previous browser, is the created, okay? That is a HTTP status code from a server to a client saying, I created the record that you requested from me, okay? And it gives back maybe some other stuff such as a date, time. It will say, hey, I'm giving you something that's in JSON format, and maybe it gives back the same document with a few extra pieces of information, like a created on or updated on, okay? So it doesn't have to. I mean, this is just my example. I could have sent you back a 204, meaning, yep, no content. I'm just giving you a header. Everything's good, everything's successful, and I'm not giving you JSON. In this case, because it's JSON, I'm just giving an example of how the server might return a modified JSON document back to the client. Now, how would we return a read, or how would we do a read? In this case, let's say that the client is now, so to your point, right? You see this? So in this case, the client needs to know the ID because that's how we're actually able to read the particular student. So in this case, the client wants to say, hey, get me all the information we know about student 12345. And by the way, this is HTTP 1.1, and it's a get operation, so we know it's idempotent, it's read-only, doesn't change any state on the server, and I want you to give me application JSON. Okay? Notice the client doesn't have to send anything else because that's it. That's how simple it was for the client. Just these 2 lines to do an HTTP GET or a read operation using REST. What's the server going to return with? Well, the server needs to return first off an HTTP status code, which is 200, meaning okay. Maybe the server might return a date timestamp. The server will say, hey, just so you know, this is going to be a message in JSON format. And here's the document that you saw before. Okay? The exact same document that was posted is now given back in a read operation. Okay. Now, how would the client be able to update the document? We talked about create. We talked about read. How do we do update? Specifically, updating the entire document. Well, we talked about that. That's the HTTP verb of put. So we're putting an entire document. We're overwriting what we had previously given you. So I'm saying put student / 12345. So here's an example where you put with the URL containing the ID, so the server knows what to overwrite. And we're telling the server it's JSON, and I speak JSON. So we're now changing things. Maybe we change the person's name, maybe we change his age, maybe we change the grade. And the server says, oh, okay, got it. That document needs to be updated. HTTP 1.1, 200, meaning, yep, okay, got it, everything's good. And I'm going to give you application JSON, and here you go. Notice in this case, it's the document that the client sent, but also the updated on timestamp has been changed. The created timestamp is the same. The updated timestamp has changed. Again, just an example of how we might want to actually represent changes happening in a database or a persistent store. What if we only want to update partially? In other words, we don't want to update the entire document, just a particular portion of the data. That would be the HTTP verb of patch. So same URL, /student / 12345. We're going to give JSON, we're going to get JSON. What's the message? Okay, we're just going to pass in an update saying the student's nickname is Johnny. Okay, this was some information that we didn't have initially, or if we had initially, we're going to overwrite it, but we're not going to overwrite everything else in the document. We're just making this one update. And the server says, okay, got it. I understood your partial update, and I made the change. HTTP 200, here you go. Here's some JSON. And notice, again, the updated on timestamp has changed, but the created timestamp is the same. And so we made the changes, and here you go. A nickname is now Johnny. How do we do a delete? Well, this is very similar to a get. We say delete, particular URL, HTTP 1.1, and I'm going to take application JSON. That's it. Very simple. 2 lines. What does the server respond with? And here's, I think, really the power of REST. The power of brevity, or the power of essentially getting the point across very, very efficiently. HTTP 1.1, 204. The 204 is in the success category. But the 204 specifically means no content, meaning I'm not going to give you a body. I'm just going to give you the header because I've made my point. You wanted to delete? Delete is successful. Done. So I don't need to give you an entire SOAP document. I don't need to give you an entire XML document. I don't need to give you War and Peace or a novel, or Shakespearean soliloquy when I just say, yep, or nope. That's the whole point. Get the job done as efficiently as possible. How do we represent errors though? Remember in SOAP, we had this concept of SOAP faults, which are exceptions. How does REST represent errors? Well, fortunately, web servers have error codes. That's how we take care of it. Now, let's imagine that we created that student document 12345, and we tried to create it again. Well, you can't create the same document again, right? So in this case, we're passing in the information to the server for a document that already exists. What's the server going to return? Well, it can return many things, but a good one to return, a good status to return is HTTP 1.1 409. 409 means conflict. Anything in the 400 area means an error on the server. 409 means conflict. What does conflict mean? A good example. You're trying to have me create a document that already exists. That's a conflict. I can't do that for you. Okay? Gives you the time. And notice, oh, whoops. I can't fast forward through this. So notice, again, when the server returns it, it just gives back the 409. It doesn't have to give an entire document back or any sort of other ceremony. It just gives a very basic information and optionally like a timestamp or something like that. But there you go. That's it. The server is now communicating, hey, you're trying to have me create something that already exists. Done. With just one header line. What about a read operation? What if I try to read something that doesn't exist? Well, this part I think you should all be familiar with, right? If you try to get a resource that doesn't exist, what's the status message that we're going to get? What's the status code? Anybody? 404, that's right, exactly. You're going to get back a status code that probably all of us have experienced, which is 404, resource not found. I get the point across very easily, don't need a lot of ceremony, done. What about the error message of delete? I try to delete a record, successful. I try to delete that record again. Well, wait a minute. I'm trying to delete something that doesn't exist, that is already gone. So what's going to happen? Well, say I try to delete that same record that I previously deleted, okay? What's the server going to respond with? 404. You're trying to have me delete something that doesn't exist. 404. So you see, as a client, I can understand this very simply. It gets the point across very easily. And this is the power that Dr. Fielding wanted to give us. The ability to do operations with a minimum of overhead, with a minimum of stress, with a minimum of ceremony to get the point across. Now that, if we tie both together, RESTful services and JSON mean that we have web services consuming HTTP operations. Web services producing HTTP status codes whenever possible. If we need more granular error, like, hey, I failed because X, Y, and Z, okay, we can put that in the body. But remember what I said, unless the client is going to take some different action based upon X, Y, Z, why return that to them? Unless they're going to change their behavior, why return that extra information? Just use an HTTP status code. That's the strength that we have here. Okay, and the simple message format means that we don't need all the ceremony of a WSDL, we don't need all the ceremony of an XSD, we don't need all the rigid hierarchies that go on there. We're able to communicate concisely, and what is the benefit that it gives us? Not only is it cleaner, not only is it more elegant, but it's more efficient. If I'm doing an operation and I have to give back a novel and receive a novel each time, well, that's going to take time. My service will not be as performant, right? But on the other hand, if I'm able to give back an HTTP status code, I can be much more efficient. I can serve a lot more users. I can scale to a much higher load without needing extra hardware or extra, processes or processors or anything like that. So RESTful web services, by being inherently more efficient, allow for better scalability as well. Okay, and lastly, we're going to talk about documentation and testing. It's now 7:55, so I think this would be a great opportunity for a break. When we come back, we're going to go over documentation and testing, how that's provided for by Swagger or OpenAPI. We're going to talk about a specific implementation using a Spring set of technologies called SpringFox. And if everything goes well, I'll even give you a live demo. All right? Thanks, everybody. We'll break for about 5-10 minutes. Thanks.